Hello, welcome to this session. This session is going to look at how to determine the water of crystallization of a hydrated salt. Without wasting much time, let's get started by looking at the objective for this session. By the end of this session, you should be able to determine the number of molecules of water of crystallization in hydrated salts using titration method. So basically, we are going to look at how you can determine the number of molecules of water of crystallization. So water of crystallization of hydrated salts. It is the definite amount of water molecules which is attached to an ion or salt in their crystalline state. And we have some equations of reactions between some hydrated salts and some acids. Because in the titration, we are going to titrate the hydrated salt with an acid. So we have to know an equation, or we have to know how such reaction occurs, and so the equation against it. And these are some of them. One is when we have hydrochloric acid reacting with sodium carbonate, a hydrated sodium carbonate salt, to give us the sodium chloride, water, and carbon dioxide. Now the X that we see in the compound is the number of water molecules, the water of crystallization. So before we can even name this compound very well, we need to know the value of X, so that we'll put there, and that tells us the number of water of crystallization. And so in such equations, this is how to balance them. So in a case where you have X moles of water, you will have your salt, and then X plus 1 moles of water, and then the carbon dioxide. Another example is between sulfuric acid and hydrated sodium carbonate, and that also we have the product there, still with the same technique of balancing it. We will need a balanced equation before we can determine the value of X. So now we can solve a problem, and the problem here is that we are still going to find the number of molecules of water of crystallization. Now in this case, M is a solution prepared by dissolving 8.2 grams of washing soda in 250 cm cube of solution in volumetric flask and topping it up to the mark. And then N is a solution of 0.2 molar hydrochloric acid. Before we proceed, we should be able to tell how we are going to approach this question and which side we are going to approach from. Now, if we look at this, if we start with the washing soda, we are going to find ourselves in troubles, because we don't have all we need. But when we look at the N, we have been given the concentration, and definitely we will know the volume. So it is convenient to start from the hydrochloric acid, which means there is going to be a relation between the hydrochloric acid and the hydrated salt. So when we start with the hydrochloric acid, we will express the concentration there in moles, since we will have the volume. And when we get the moles, we can now look at the relation between the two compounds. Then we will now go to the side of the hydrated salt. But let's look at what follows. So this is the instruction, and after that we have to calculate the concentration, the amount concentration of the hydrated salt, that is M, and then we have to find the value of X, that's the number of water of crystallization, and also percentage by mass of water of crystallization. So let's continue. We are to take the average volume of N, which is the acid used, as 28.60 cubic centimeters. So let's start. We have been given the concentration of the acid, and that is 0.2 moles per dm cube. Usually we would have to interpret the concentration so that we can take it from there. So 0.2 moles per dm cube means that 1000 cubic centimeters of the HCl contains 0.2 moles. If that is the case, now in the task, the acid was put in the burette, and so the average titer is the volume of the acid used, which is 28.6. So if the 1000 contains 0.2, then 28.6 will contain 28.6 times 0.2 divided by 1000, and that gives us 0.00572 moles. So it is this volume of the acid 28.60 that reacted with the volume of the hydrated salt, that is the 25 cubic centimeters that was used. So this volume as against that volume. So we are going to find the corresponding moles of the hydrated salt in that small volume. Then now we take it to the big volume. But before we do that, we need to know the relation between them. And from this equation, 2 moles of hydrochloric acid reacted with 1 mole of the salt. So if that is the case, if 2 moles is equal to 1 of the salt, then 0.00572 moles of HCl is going to give us half, or 1 over 2 times 0.00572 moles, and that is going to give us 0.00286 moles. So this is the moles of the hydrated salt. Now that we know this moles, this is the moles contained in the volume, the small volume that we use. So we have to take it back to the 1000 cubic centimeters. So the 0.00286 moles is the moles in the 25 cubic centimeters. So if 25 is equal to 0.00286, then 1000 will be equal to what? So we do such mathematics, and our answer is 0.1144 molar, or mole per dm cube, of the hydrated salt. So this is the amount concentration of the hydrated salt. The next one is to find the mass concentration, and here rho is given as mass over volume, but volume in cubic decimeters. Remember, in the question we were given mass and volume. They said the solution was prepared by dissolving 8.2 grams in 250 cubic centimeters. So in this case, we just have to convert the volume from centimeters to decimeters. Then we divide the mass by the volume to have our mass concentration. That is 32.8 grams per cubic decimeters. We will not be able, at this point, if we are to find the mass concentration, we cannot use the other relation where we will come in with the amount concentration and the molar mass. Why? Because there is problem with the molar mass. There is X there. So without knowing X, we cannot find the molar mass. So we cannot use that relation. Okay, so for instance, what we have over here, if we wanted to use that relation, then the molar mass here is 106 plus 18x grams per mole. How do we deal with X? It will be hard for us. That's why we have to find mass concentration using another relation. Now, knowing that, we can now say that molar mass is equal to rho over amount concentration. We are now going to look for the value of X, or the number of water of crystallization. So we can calculate the molar mass using the relative atomic masses, and that is what we have done to get the 106 plus 18x. The same molar mass, remember, has a relation with mass concentration and amount concentration, and the relation is mass concentration over amount concentration. If that's the case, we can do substitution. We can substitute the 106 plus 18x in place of the molar mass. And since we have calculated to know the mass concentration and amount concentration, we can find the value of x. And so 106 plus 18x is equivalent to, or is equal to 32.8, which is the mass concentration, over the 0.1144, which is the amount concentration. What is left is mathematics to find the value of x. So we work x out and we have 10. The 10 means that the number of water of crystallization is 10. So wherever we see x in the compound, we put 10 there. So let's continue. And the next point, the next task is to find the percentage by mass of water of crystallization. And here is the mass of water in M over total mass of M times 100%. Without the number of water of crystallization, we wouldn't be able to do that. Thankfully, we have already found it, so we just do substitution. The mass of the water, or the molar mass of the water, is 18x, and the molar mass of the whole compound is 106 plus 18x. But now we know the value of x, so we put there. That is 18 times 10 over 106 plus 18 times 10 times 100%, and that gives us 69.2%. Okay, so my good friends, we are ending the session with a task. Please try and solve it. Let's meet again in the next session.